Okay, so let's continue with the integration of inverse hyperbolic functions. Okay, so for the integration question, whatever it is, we need to try to solve using the substitution. Okay, so let's try. U equal to x squared minus 16, then differentiate the u with respect to x, you will get the 2x. Okay, then try to substitute into the equation. So 1 over square root of, okay, this one we already let as a u, so your dx now becomes the du over 2x. Okay, as you can see here, there is x, which is you cannot cancel with the other x, so means that you cannot solve using the substitution. Okay, if you can't solve using the substitution, so what you need to do is you need to try using a squared u squared. Okay, so here you have the x squared, so this one we need to let as the x as a u squared and then you have a constant here, we need to let as the a squared. Okay, so now u squared equal to x squared, then u will equal to x, then you need to differentiate u, you will get the du dx, and then x will become 1, therefore dx will equal to du. Okay, and then for the a squared equal to 16, then a will equal to 4. Okay, so now substitute back into the equation, then it becomes the 1 over square root of u squared minus the a squared, dx now becomes du. Okay, so after you got this equation, now look at your appendix. Okay, square root of u squared minus the a squared. Okay, square root of u squared minus the a squared. Okay, which is will equal to inverse hyperbolic cos x over a. Okay, so now as we know, this one will equal to inverse hyperbolic the cos u over a plus c. Okay, the last step is substitute your u and a, then the answer will be inverse hyperbolic cos, our u is the x, our a is 4 plus c. This is our answer. Let's look at the c. Okay, c, you have the 2x square root of 1 minus the 4x power of 4 dx. Okay, so this question, remember, we need to start with the substitution. Okay, let u equal to 2x, du over dx equal to 2. See, when you want to substitute into the equation, then that x on the denominator is still there. Okay, so what if we take the u equal to 1 plus the 4x power of 4? So when you differentiate, you will get a 16x cube. So when you substitute into the equation, and then that x cube you can cancel with the x on numerator, but then at the end you still got over x squared, so means that there is a x, then your substitution is still wrong. Okay, so since u equal to 2x we cannot solve by using the u equal to 1 plus the 4x power of 4, we cannot solve, then we need to use the a squared u squared. Okay, so this one become the a squared, so a squared equal to 1, a equal to 1, and then the u squared equal to 4x power of 4, then your u will equal to 2x squared. Next, you need to differentiate u, you will get the 4x, then dx will equal to du over 4x. Okay, so next substitute into the equation. So 2x over a squared plus the u squared, now your dx become the du over 4x. Okay, so now this x we can cancel with this x, and then you can simplify the 2 and 4, then you will get the 1 over 4. Okay, so 1 over 2 integrate of 1 over square root of a squared plus the u squared du, So now this one you can look at to the appendix. So integrate of the a squared plus the u squared, then you will get the inverse hyperbolic sine. Okay, so this one 1 over 2 is still there because it is a constant, so integrate the 1 over square root of a squared plus the u squared du. So this one will be inverse hyperbolic sine u over a plus c. Then your final answer is 1 over 2 inverse hyperbolic sine u is 2x squared, and then a is 1 plus c. So this one you have the integrate of 1 over square root of the x squared minus 2x plus 5. Okay, so now you have a quadratic equation inside the square root. So when you have the quadratic inside the square root, so what you need to do is you need to use completing the square. So the formula for the completing the square is x minus x plus b over the 2a squared minus b over 2a squared plus c. Okay, so now for x squared minus 2x plus 5. Okay, before we proceed with the CTS, you need to make sure that the coefficient for x squared, okay, whatever numbers in front of the x squared, it must be equal to 1. If there is other numbers, there is other symbols, so you need to factorize that symbol first. Okay, so this one, since your a is equal to 1, then you can straight away completing the square. Okay, so the x plus, so now your b is a negative 2 over 2 squared minus negative 2 over 2 squared plus 5. Okay, so at the end you will get the x minus 1 squared minus negative 2 divided by 2 will equal to negative 1. Negative 1 squared, you will get 1 plus 5. So at the end you will get the x minus 1 squared negative 1 plus 5, then you will get 4. Okay, so now whatever you got after the UCTS, you substitute into the question. Then your question now become x minus 1 squared plus 4 dx. Okay, so the next step is you need to use the a squared du squared. Okay, here since you have the x here, so this one become the u squared, and then here you have a constant, so this one becomes a squared. Okay, so then u equal to x minus 1 squared, the u squared equal to x minus 1 squared, then u will equal to x minus 1, then you differentiate du over dx, you will get equal to 1. Okay, and then the a squared equal to 4, then a will equal to 2. Okay, so now substitute into the question. You will get integrate of 1 over square root of u squared plus a squared, and then your dx become du. Okay, so after you substitute into the formula, so now look at to the appendix. So the a squared, so the u squared plus the a squared, you will get the inverse hyperbolic sine. Okay, so here the answer is inverse hyperbolic sine u over a plus c. Then substitute your u and a, so our u is x minus 1, and then a is 2 plus c. So this is the answer. So I hope you can answer for the all the example that are all the examples and also the exercises.